Hi guys, welcome back to Data Every Day. Today we are looking at a data set of insurance customers. So we have a bunch of, I think it's like 1,300 different customers and a few features about them, and we're going to be trying to predict the premium charges for the insurance that a given customer will incur. Um, so let's hop into the notebook. I also want to today build an interactive widget that will allow us to make predictions based on user input. So I'm going to import NumPy and pandas for working with the data. For pre-processing and for building the pipeline, we're going to use the train test split function, one hot encoder, standard scaler, column transformer, and pipeline object from sklearn. For the model, we'll just use linear regression, and then we need these two to build the widget. So we're going to use ipy-widgets, which I'm importing as widgets, and we're using the display function from ipython.display to be able to display the widgets. So let's go ahead and import all of that, and we'll load in the data using pandas.read CSV. So we can grab the CSV file up here. I'll just copy the file path and paste it in, and we can take a look. Alright, so here it is. We have 6 columns. So not too bad. I mean, it's a very simple data set, and it's very clean as well. I don't think we have any missing values in here. Yeah, no missing values. We also have some categorical features, so we're going to encode those in the pipeline. So let's start pre-processing. I'm going to create a function called preprocess inputs. It's going to take in a data frame, and all this is really going to do is split the data up into 4 sections, since we don't really have to do any real pre-processing here. So we're going to first split into x and y. So split df into x and y, where y is what we're trying to predict. So that's going to be the charges column. This is the column we're trying to predict. And then x is all the rest of the data. So we'll drop charges from axis 1. Then we'll do our train test split. So now we'll split it into x train, x test, y train, and y test. We'll send 70% of the data to the train set, use the other 30% for evaluation. So we'll use the train test split function from sklearn. We're just going to pass in x and y, specify our train size to be 70%. Shuffle will keep as true so that it'll shuffle the data before it makes the split. And then we'll also give it a random state so that we can reproduce the shuffle. And we'll just go ahead and return those 4 sets of data. Alright, now I want to get them back over here. So let's just say that equals pre-process inputs, and we'll pass in data. Oh, I have to run the block. Okay. So x train is 70% of the data, not including the charges column. Y train is the same 70%, but just the charges column. Alright, so now we're going to build our pipeline. Building the pipeline and a training. So the pipeline is really going to just focus on encoding the categorical columns and then scale the data. So we need to create a one hot encoder for this. So I'm going to use the one hot encoder object from sklearn. I'm going to include sparse equals false so that we don't get a sparse output, and also I'm going to include drop equals if binary. So what this does, if we have a binary column where there's only 2 unique values in the column, we'll drop one of the columns, since each one will just be like the inverse of the other if we're doing a one hot encoding. Alright, so let's call this OHE. And what I actually want to do, no, actually we won't call it that. What I'll do is I'm going to put this one hot encoder inside its own pipeline. So it'll be the only step in a pipeline. We'll call this one hot, and it'll be that one hot encoder. And then this pipeline we'll call nominal transformer, because it will be used to transform the nominal columns. Let's actually define the nominal columns up here. Nominal features. There's 3 of them, I believe, which is sex, smoker, and region. So we'll just put those in there. Alright, and then we're going to build a preprocessor. This is just the part, the actual, like, this tells the model which columns to target with our nominal transformer. That should be transformer. So this will actually be a column transformer object from sklearn, where we give it multiple transformers and we specify which columns to use these transformers on. Now in this case we're only going to be using this one transformer. So let's call it nominal, and that's going to be our nominal transformer, and we're going to use it on nominal features. And we just have to make sure in here to type remainder equals pass through, because if we don't have this enabled, what's going to happen is any columns that are not transformed by some of the transformers specified in the preprocessor will just be dropped. So we want to make sure they pass through along with the transformed columns. Alright, then we'll build the model. This is going to be a sklearn pipeline. The steps here, we're going to have 3 steps. The first will be the preprocessor, and that's just preprocessor that we just created. The second one will be the scaler, and this will be a standard scaler, which will give each column a mean of 0 and a variance of 1, so that all columns have the same range of values. And then we'll have our regressor, which is just linear regression in this case. Alright, so now we'll fit the model. Let's run that. Model.fit xtrain ytrain, and it's been fit. You can see first the one-hot encoding is applied, then we scale, and then we make predictions with the linear regression model. Now we'll get some results, and then we'll build that widget. So I guess we should get a set of predictions, which I'll call ypred from model.predict on xtest. So if we look at ypred, these are the predictions, one prediction for each example in xtest. Ytest includes the actual values that for each example in xtest. So we want these to be similar. We want them to be as close to each other as possible. So one way that we can measure the effectiveness of the model is by calculating the error between the two. So we can do this by taking our true values and subtracting the predicted values. And this will be an error for each training example. Now we want one number to sum up the model's performance, so we could take the average of this, but the problem is there's positives and negatives in here, which will actually cancel each other out when we sum them all up. So what we can do to counteract this is to square them element-wise so that they're all positive. And then we can take the mean. So numpy.mean. So this is a single value that represents how well our model is doing. Only problem is it is in the squared unit of the original target column. So I actually don't know the currency here. Does it say? No, it doesn't say. It just says the premium charged. Let's assume it's in dollars. Then this is the squared dollar error. So what we do to counteract that is square root this again to get the average error in dollars. So we're $6,000 off each prediction on average. So I'm not sure how good that is exactly. We should look at ytest and look at the describe function to see the distribution a little bit. We could visualize it also if we wanted. But it looks like the minimum is 1,100, the maximum is 60,000, and the median here is 9,800. So being 6,000 off is not so great. It's not terrible considering the range here, but it's definitely not so good. Now we are using a pretty simple data set, not too many training examples as well. I'm sure we could probably get a better result. We're using a very simple model as well. Let's see if maybe using a more complex model will give us better results. If we let's from sklearn.ensemble, we'll import random forest regressor, which tends to almost always give better results than a simple linear regression. So just put that in, fit that, and let's compare it to the old RMSE. And it went down substantially. Okay, so why don't we just use random forest? So I'll just put this at the top. I mean, this isn't really a model optimization video, but the better performance is better. Okay, so we're about $4,800 off now each time. So another way we can analyze the results of the model, this is called the RMSE, by the way, which is the root mean squared error. See, this is the error, this is the squared error, this is the mean squared error, and this is the root mean squared error. Another way we can analyze the performance is by comparing it to the null model or baseline model. So if we look at y-test, if this was all we were given, or I guess it would be y-train actually, if we were just given y-train and we wanted to build a model without any input, no x-train, just y-train, the best thing we could come up with would be to predict the mean every time. So by predicting the mean every time, we'd get some errors of our own. So let's try that with the test set. If we take y-test and subtract y-test.mean, we get the error for each training example if we predicted the mean each time. And this is called the baseline model, or null model, depends on what you want to call it. But we can sort of calculate a similar thing that we did up here. We want to square this first, so we get them all positive. And instead of taking the mean, I'm just going to sum them up and then compare this sum to our sum of squared errors. So this is the sum of squared errors for the baseline model. Let's now do the same thing for our model. So all we do is replace y-test.mean with y-pred. So this is the sum of squared errors for our model. This is the sum of squared errors for the baseline model. We can almost, we're not sure how they compare, but we would like to sort of put them in a ratio to try to get a sense of that. So what we can do is put them in a fraction, a ratio, where we use our errors as the numerator and the baseline error as the denominator. And this has the effect of being 0 when we have 0 error, and being positive infinity when we have infinite error. I mean, you can't really have infinite error, but the limit would bring you to positive infinity. So this is sort of a nice way of visualizing or understanding how you're doing relative to another model. And the reason I use the baseline model here is because the r-squared score is calculated as 1 minus this value. So the reason we do 1 minus is because now when we have 0 error, this whole fraction goes to 0, and 1 minus 0 becomes 1, which is like 100%. And when we have infinite error, this whole fraction goes to positive infinity, and 1 minus positive infinity goes to negative infinity. So the r-squared score is a measure of how well your model is doing compared to another model on a scale from negative infinity to 1. So if you have an r-squared of 0, what that means is you had this fraction is 1, because 1 minus 1 is 0. So if this fraction is 1, it means that your error is exactly the same as the baseline error. So an r-squared of 0 means you're doing exactly the same as just predicting the mean every time. An r-squared of 1 means you're doing 100% better than predicting the mean every time. Your error has gone completely to 0. So let's see what we get. We got an r-squared of 0.83, so that's fairly good. It's saying we have an 83% reduction in sum of squared errors between the baseline model and to our model. Okay, so let's call this R2. Let's put this up by RMSE, and let's just print these out. So we'll print the RMSE. Let's display this to 2 decimal places. Oops. And we'll format it. We'll call .format here, pass in RMSE. Then we'll print out the r-squared score. I'll display this one to 5 decimal places. And we'll format this using R2. Alright, there it is. So I'm not going to go into model optimization or anything. Just going to leave it as that because I want to get to this interactive widget. So this is sort of an example of, well, both how to use IPy widgets, but also to show how using a preprocessing pipeline can be beneficial if you want to deploy a model into production. So if you were really going to go for, if you were actually deploying the model, you wouldn't use IPy widgets. You'd probably put it on some sort of web service. But this is sort of like a really quick and dirty way to see sort of how your model would function as an application. So if we're using IPy widgets, which we imported as widgets, the widgets module has a whole bunch of different objects that we can use, such as int slider. This is just becomes an integer slider. Default it goes between 0 and 100, but we can change that. We also have float slider, which I'm sure you can guess what it does. It's just float slider. For this one, we're also going to use toggle buttons for the binary variables. And that, actually, we should specify the options here. Why don't we just start making them? So this will be our age. Let's look at xtest. Actually, let's look at xtrain. We should be looking at the train set here, because we want to input values that our train set was used to seeing. So what I'm going to do is get a little more information about xtrain. I'll do xtrain.describe so that we can see the numeric variables and their distributions, and I'll also see the unique values inside the categoricals. So I'll make a dictionary that maps a column, the column name, to a list of the unique values in that column in xtrain. So .unique xtrain excuse me, xtrain subcolumn .unique, turn it into a list for every column in xtrain.select dtypes object columns. So for all the object columns, we're just going to get a list of the types of values in the column. Alright, so with all this information we can proceed. First, I want to make one widget for each feature. Right, so let's do the age one. Here, this is going to be the age slider. So the value, this is the initial value, and I'll just initialize it to the median, which here looks like 38. So let's just set it to 38 to start. We'll set the min, which will be, we'll just make the min in the training set 18. The max, which would be 64. And then I will give it a step. I think it's 1 by default, but I'll just specify. And give it a description. So this will just be age. Alright, and that looks like this, which is what we want. So we also want to do this for BMI and children. I guess let's do children first, because that's also an int slider. So this just becomes children. We have a min of 0, a max of 5, and a median of 1. So min of 0, max of 5, median of 1. That's our children slider. Then we'll do one for the BMI. So for this one, we have a minimum, I'll just round down up here, minimum of 15, maximum, I'll round up, of 54, and a median of 30. Let's do that. Float slider. So value is 30, minimum is, what was it, 15? 15, and a maximum of 54. Now the step here we'll step by hundredths and give this a description, BMI. Okay, there we go. That's our float slider. These are our two int sliders, and I guess I'll put them in this order. We're going to put them all together when we're done. Alright, now let's do the binary variables. So we have smoker and sex, where here the unique values are yes and no. Here it's male and female. So let's go and do that. I guess we'll do the sex one first. So here we'll put some options. This will just be a list of all these selections we can do. So I'm going to make them the same as the values inside the data. So that's female and male. And we'll give it a description. It's just the name of the column. We'll do the same thing for, what was the other one? Smoker, which is yes and no as the values. So no, and yes, and there's the title. Okay. Oh yeah, these look like this. So you can choose between them. And then the last one to do is the region. So that's this one here. And that has 4 values: northeast, northwest, southeast, southwest. And I'll keep that order. So this will actually be a drop-down menu we'll do. So we'll just drop down with the options here. Options will be north, east, northwest, southeast, and southwest. Alright, I'll give it a description. Region. Okay, and that looks like this. So the reason we did this is because let's give these names. Right, we want to give these names. So I'll call this age widget, and this will be BMI widget. This is children widget. This is sex widget, and a smoker widget, and then there's one more, which is the region widget. Alright, now run all these. In fact, let me put them all in the same block. Okay, here they are. Sorry. So we can use the display function to display them all at once. So this is from ipython.display. We'll display age widget, BMI widget, children widget, sex widget, smoker widget, and region widget. And now they all come up at once. And the reason we do this, the way we can use this is to take one of them and use the .value attribute to return the value. Now if we change this and recompute the value, it'll update according to whatever's on the slider. So now what we want to do is use these inputs, whatever the user specifies, as input to the model. So what we'll do is create a button. So we can do widgets.button and give it a description. Well, this is a predict button, so it'll be predict widgets. And so this is the predict button. Right now it doesn't do anything. What we wanted to do is take these inputs and feed them into the model. So the way we can do this is by specifying a function to use, which will be the onClick function for the button. Let's call it make prediction. And it takes in a button as argument. We're not going to use this though. Okay, so X will be the input to the model. This is going to be a single vector. I'm going to encode it as a data frame though. So it's a pandas data frame, and we're going to use the dictionary constructor for the data frame. So that'll map a column name to the value for the column. So for age, the value we want is the age widget dot value. For sex, which we'll do next, actually it's very important that we do this in the same order as what goes into the model. So you can see we need age, sex, BMI, children, smoker, and then region in that order. So we'll put them in that order. I forgot children. Alright, and the last one is region. Okay, let's just indent these up a little so that we can view it more easily. Okay, So I do have to specify an index here, which is just 0 since it's one example. Okay, so what we do is when we call this function, we create this sort of input to the model based on the values of the widgets, and then we pass that into the model. So model.predict, pass in x, and let's call this our prediction. Alright, now we want to print the prediction to the screen. There's another widget we can use called widget.output, widgets.output. We don't have to specify anything in here, but we'll give it a name. Let's call it prediction out. And what we can do over here, if we use with prediction out, then any print statements we write will be sent to the output. So if we display, let's put it here, let's display prediction out. You can't see anything right now, but if we were to print hello world, then when we click the predict button, sorry, we didn't assign this. Okay, let's do it this way. I'm going to call this predict button, and we'll display predict button. But first I'm going to assign the onClick function. So that will be predict button dot onClick, and we pass in the function name here, so that's make prediction. Now we click this, we should see something on the output. Children widget is not found. Oh, I wrote children. Okay, there we go. Alright, now we run this, it says hello world. Run it again, it'll keep doing it. So what I want is not for it to keep stacking, but I want it to clear each time. So what we can do up here is do prediction out dot clear output. Now we run this, and it'll keep clearing it and then writing it. So if I change that, you can see it changes. All right, so I don't want it to output the hello world. I want it to output the prediction. All right, now it is displaying it as like in a list, so let's just take the first value there, and we can see it. All right, so let's actually just print this nicely. Prediction is the prediction. All right, and you can see it just like that. Actually, let's format it a little. So we'll display it to, let's say, 4 decimal places. Format with prediction sub 0. Okay. All right, that's good. Okay, let's put this all together into one thing. So I'm going to take this. We don't want to display them separately. We want to display them together, like that. And let's put this here. Alright, so I actually want to define this above the onClick function and then display. Alright, so let's put this function over here. So we create the button, we create the output, we write the function for the onClick, we set the onClick function, and then we display them both. Let's now put this up over here. And I'm going to take all this stuff and put it on the same display, like that. Alright, and this should be the whole widget. So let's give it a try. Just delete these at the top. Let's take a look. Alright, here it is. So we pick an age, we pick a BMI, we pick some number of children, we pick male or female, smoker, and then pick a region and predict. And there it is. Now if we change one of these and repredict, the prediction will change because we're passing different inputs into the model. Yeah, so that's it. And you can see why having using the pipeline is important, because if we were to pre-process before we write the model, we'd have to basically declare these as like one-hot values. Like we'd have to do the pre-processing like in here, in addition to doing it outside. So by doing a pipeline, it allows us to pass in like human readable inputs to the model like this. All right, and I'll just put like one little disclaimer here. We can actually, I found you can do this cool sort of HTML stuff. We can create a div with a class alert and alert block and alert info. And we'll put a little note here. So I'm going to bold it with strong. Note, this widget can only be accessed in an interactive session of the notebook. Alright, and then it looks like that. So this is just because you have to run the notebook to be able to use this. Once we publish it to Kaggle, you won't be able to. I mean, you can tweak the sliders, but the predict button won't work. All right. As far as I'm aware, I'll double check that. Okay, and that will sum today's video. So thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.